Okay, let's go ahead and get started. Let's start with the introduction to the ARM assembly. Note that this is an introduction, so some of this information might be too basic for you. If that's the case, feel free to go to the next lecture if you like, but we're starting from the ground up, and I have no assumption that you have previous knowledge about the directives, for example, so we'll go ahead and get started from the basics, okay? So we'll talk about different sections of the code, what they mean and how they actually affect our program. We'll talk about memory content. We'll talk about directives, specifically three basic ones, and then we'll talk about how to allocate space for variables and how to skip and fill content in memory. We'll talk about the align directive. We'll talk about code control and macros. So these are different ways that basically we'll talk about them actually when so I'm not going to get ahead and get ahead of myself here. So what I did is I wrote a small program for you to see, and let me switch to that. Okay, so in this program, or this is basically a few lines just to demonstrate what the different sections of an assembly code would look like. You have words that start with a dot, like dot data, dot text, etc. You have comments. So these are comments. You have entry points. You have labels. So what do they actually do? So the first type of thing you will see here is the directives. So for again, the dot data, the dot text, the dot global, and the dot end. These are directives, and the goal of using directives is to tell the assembler what to do with what comes after the directive, like the instructions or the data, or if you want to allocate, for example, if you want to store a value in memory, should it go in the dot text or should it go in the dot data? Well, if it's a value that you need to store, it looks like it's a variable, and you don't mix and match variables necessarily with in the same area in memory as your instructions. So the dot data directive, basically this section contains variables and space allocations. And notice that I could write this comment using /, double / to indicate what this section is. I could also use, or I can use the @ or the @ sign to indicate a comment as well. So I actually could have done this if I wanted to. Either way is fine in this example. You can also write comments using the / with the asterisk. When you have multi-line comments, in this case, I wrote a comment here about the global directive with the start. We'll read it together in a minute. And the last, well, not the last one, we also have labels. So for example, like _start, I can have a label here that's called, you can call whatever you want. You can call it loop, for example. Later on, we might want to do a loop, so when you need to repeat a set of instructions, you can branch back to this loop. How do you know that? Or how do you know to which instruction you need to go to? You don't necessarily need to memorize the address of the instruction, so instead you use a comment. So maybe here you have loop 1, and then you have some instructions, and then here you have loop 2, and then you can branch back and forth and whatnot. But the idea is that you don't have to remember the line or the instruction address to jump to. We'll talk about that later. So labels are actually very helpful. They are easily read for us in English, so we can actually jump to that loop or do that label. Okay, so let's go back and focus on the sections that we have. So we said we can write comments, and comments are usually are written with double /, the @ or the / with the asterisk. We have things that are called labels, and directives. And directives tell us what, whatever comes here, this type of information, where does it go in memory? And in this case, the data tells the assembler, hey, what comes after this should be located in the section of memory where the data declaration should happen. Okay, the .text is the second major directive, and it tells the assembler what comes after is code. These are instructions. So put this information in the memory address where the instructions go. And the other one that is also common is the .bss, but I'm not gonna use it in this series. So just know that there's other directives called the .bss. And why am I making this distinction? Because there is some information that you need to know. So the .data, since it hosts variables, like it initialized global, it's a place where you initialize global variables or static local variables. It means that this section is, you can read and write to that section. So this section is can be read or written to, right? So that data section or the directive can be read or written to. On the other hand, the .text is where your instructions go. So because you don't expect the instructions to change after you start the program, like the instructions don't change themselves, this section is read only. So I have another note here that this section is read only. The .bss is usually declared but uninitialized. It's used for declared but uninitialized variables. We're not going to use that here, so I'm not going to worry about it. So anyway, so these are your main points here. The .global tells the assembler that this symbol is visible throughout the program. It's global. And the very last piece of information I'm going to tell you about this is that the underscore start is the entry point of our programs throughout the entire set of lectures here. It's just that if you've watched the previous playlist that tells you about how to set up the Intel Monitor program, you notice that the underscore start is basically the entry point of an assembly program on this platform. Whether you use this platform or use, we'll talk about the other one maybe later, the underscore start is where it goes. Think of this as your main function in a C. When you write C code, you have your main function. Your main function is the entry point of your program, and then whatever comes afterwards actually needs, first you execute the your entry point is the main function, and then whatever instructions come afterwards will execute sequentially. So if I compile and download this to my board, so let me do that. I'm gonna pause it for a second. Okay, if I download this to the board, I cannot really do any modification, by the way, because it's connected to the board. So if I look at memory, there is really no sense on what's going on here, and it's simply because I did not declare anything. So there is nothing readable, at least for our purposes. If I take a look at the D-assembly, basically the instructions, there are no instructions stored anywhere. It's all question marks because there's nothing here. Because the program is empty. There's nothing really in the program. So let me go ahead and add another piece of information here. So let's say I'm going to declare, I want to declare an array or a sentence, right? Or I want to declare ASCII characters, right? So I can use the ASCII directive, and we'll talk about different directives later, but I just want to drive some point home here. So let's say I have an ASCII that's called hello ARM, and now if I compile and download that to the board, I should see hello ARM stored in memory, and I'll show you how to do that in a second. Again, I'm going to pause it to save some time. Okay, it's loaded. So now if I go to my memory tab, I will see hello ARM. So you see these HELLO for hello and ARM. And you can see the equivalent, the hex equivalent of these characters. So 48 in hex is capital H and so on. Don't worry, we will spend more time figuring out how to read the memory content. So this is not the place to do so, though. So what I'm going to do is one more time disconnect the board. And actually, if I went to my disassembly, I will still see there's no instructions here. So I'm going to go back and just add one instruction, just so that I can show you. Let's say I'll do a move. Let's say some value. Let's move some value to R0. Okay, so this is an instruction that's moving the value of 31 into register R0. I'm going to compile and download to the board. I'm going to pause it again. Okay, it's loaded. So now if I go back to my memory, I still have my hello ARM declaration. Now if I go to my disassembly, oh, now look, I do see some instruction that's actually stored in some memory. This is the instruction that I wrote, move R0 hashtag 31. This is the value of, this is what the instruction look like in hex, but we're not gonna really dive into that right now. But if you notice that the assembler did place this instruction at address 0000, and it did place the hello message or hello ARM at address 18 hex. This is the first byte of that hello, right? And this is address 10 hex plus 8. So this is address 18 hex. And you can notice that the instruction is actually placed on the top. So 1F00 A0E3 is at address 000. If I go to my disassembly, this is my address. This is the instruction that I have in memory. Okay, it's flipped because of the Indianness here, but don't worry about it. We'll talk about that maybe later. So one more time, what I'm going to do is I'm going to place something else. So let's say I want to, let me disconnect. I'm going to place some more data here. So let's say ASCII, nice to meet you, right? And I'm going to show you that those instructions or those two different things will go in their respective memory place. So let's say I'm going to do another, I'm moving another piece of information to, or number 88 to R1. And you'll see that nice to meet you will actually be placed right after hello ARM. And then the second move instruction is going to be placed after the first one. So if I go back to my memory, here we go, hello ARM, and then nice to meet you is following it right away. And in my disassembly, I have my first move instruction at address 0, and the second move instruction is at address 4. So the point here that I'm trying to say is those directives really tell the assembler where to put what comes after. Okay. And another thing I would say is some of these directives are actually, they have, so for example, I don't want to call them subdirective because they're not really subdirectives, but for instance, this is whatever is before this line is where all my data goes, regardless whether or not the data is an ASCII character or a byte or a word or a fill or whatever, right? That's where the data normally goes. And then whatever is between that line and this line, right, that's where all my instructions will go. And that way we can keep things organized in memory. Anyway, that's it. I don't want to make it too long. I hope that you enjoyed this lecture and you learned about different code sections in ARM assembly, and you learned some introduction to the directives in ARM assembly. Thank you for watching.